Chapter 3.5, Solving a System of 3 Linear Equations. Before the end of this video, you should be able to solve a system of 3 linear equations with 3 unknowns using substitution or elimination. Okay, so I'm going to give you a system of 3 linear equations, and you are going to solve them. The first thing you want to do is eliminate one of the variables. So I'm going to pair up these two equations. 2x minus y plus z equals 4, and x plus 3y minus z equals 11. And I'm going to add them together and then eliminate z. So 3x plus 2y equals 15. Then I'm going to pair up another two equations. Not those two. How about let's pair up 1 and 3 to eliminate the z again, so I'll have two equations that have only two variables. So I get 6x equals 18. Now on this one, you looked up because you can actually just solve for x. And you get 3. So x is 3. Now I need to find y and z. All I have to do to find y is take my 3 and plug it into my equation I have over here. So 3 times 3 plus 2y equals 15. That's 9. So if I subtract 9 from both sides, I get 2y equals 6. So y must be 3. So x is 3 and y is 3. Now I need to know what z is. So I'm going to take 3 and 3 for x and y and plug it into one of the original equations. You can plug it into whichever one you want. Let's take them and plug them into that. Let's do the middle one. So we're going to plug them into x plus 3y minus z equals 11. So we'll do 3 plus 3 times 3 minus z equals 11. That's 3 plus 9 minus z equals 11. 3 and 9 makes 12. Subtract 12 from both sides, and you get negative z equals negative 1, which means positive z must be positive 1. So your answer is 3, 3, and 1. You can put it in an ordered pair, 3, 3, 1, like this. Okay, let's try that again with this system of equations. So we're going to pair them up so it eliminates one of the variables. Let's pair up these two, and then we'll pair up these two. So the pink, we paired up x minus y plus z equals negative 1, and then x plus y plus 3z equals negative 3. So I get 2x plus 4z equals negative 4. Now the blue equations, I'm going to do x plus y plus 3z equals negative 3, and 2x minus y plus 2z equals 0. So the y's cancel again, and I get 3x plus 5z equals negative 3. So I'm going to take that as my new system of equations. 2x plus 4z equals negative 4. And 3x plus 5z equals negative 3. So I'm going to solve that system just like we did before. I don't have any opposites, so I'm going to have to create some opposites. Let's multiply the top by negative 3 and the bottom by 2. So that'll be 6. So this is going to become negative 6x minus 12z equals 12. And the bottom one's going to become 6x plus 10z equals negative 6. Combine them and you get negative 2z equals 6. So z must be negative 3. Now that you have one of the numbers, you can take it and plug it into one of the equations with just two variables. So that'll be 3x plus 5 times negative 3 equals negative 3. 3x minus 15 equals negative 3. Add 15 to both sides and you get 3x equals 12, so x must be 4. Now that you have two of the variables, you can plug it into one of the originals up here. So instead of that top one, we're going to plug in 4 for x and negative 3 for z. So that's going to be 4 minus y minus 3 equals negative 1. So 4 minus 3 is 1 minus y equals negative 1. If we subtract 1, we get negative y equals negative 2. So positive y must be positive 2. So my answer is x is 4, y is 2, z is negative 3. Okay, moving on to another system, we're going to do the same thing here. So we're going to pair up. Let's do 1 and 3, and that'll eliminate x. Then we'll have to work a little harder to eliminate the other x. But if we line up my equations I just showed in blue, we'll get x plus y plus 2z equals negative 3, and then negative x minus 2y plus z equals 10. So if we combine that, I get negative 1y plus 3z equals 13. Now let's just do these bottom two in pink, and we're just going to have to work a little harder to get rid of one of our variables. Okay, I'm trying to eliminate the x's, but these won't eliminate, so I'm going to have to multiply the whole bottom equation by 2. So I'm going to multiply it by 2, and that's actually going to give me negative 2x minus 4y plus 2z equals 20. And then when I combine them, those cancel, and I get negative 3y plus 5z equals 27. So I have a new system. This equation and this equation I'll pair up. Negative 1y plus 3z equals 13. And negative 3y plus 5z equals 27. If I multiply the top equation by negative 3, I will have opposites. So we're going to write that down here. That's going to be positive 3y minus 9z equals negative 39. And when I combine, I get negative 4z equals negative 12. Divide both sides by negative 4 and you get z equals 3. Now take your z and plug it into one of the ones with two equations. So I'm going to do that one. That's going to be negative 1y plus 3 times 3 equals 13. That's 9. So if I subtract 9 from both sides, I get negative 1y equals 4. Divide both sides by negative 1, so y equals negative 4. Last thing I need to do is find out what x is. So I'm going to go back to one of my originals. X plus y plus 2z equals 3. Plug in my y and z. So x minus 4 plus 2 times 3 equals 3. Minus 4 plus 6 equals 3. That's 2. So x plus 2 equals 3. So x must be 1. So my solution point is 1 for x, negative 4 for y, and 3 for z. Okay, if you feel brave, you can try this one on your own. I'm going to give you the answer, but I'm not going to give you the whole solution. So pause the video, try it on your own, and I'll give you the answer in just a second. Okay, the answer for this one is going to be 4, negative 1, 2. You can also solve a system of 3 linear equations, 3 unknowns with substitution. So you can take what one variable equals and plug it in for the other. So I see that the second equation right here is going to be easy to solve for x. If I just move that 5y over, I get x equals negative 5y plus 9. Now I am going to replace the x's in my other two equations with what x equals to solve it. So if I take that and put it in the top one, I get 2 times negative 5y plus 9 plus 3y minus 2z equals negative 1. Negative 10y plus 18, I'm just distributing, plus 3y minus 2z equals negative 1. That's negative 7y minus 2z plus 18 equals negative 1. And then I'm going to subtract 18 from both sides just so the variables will be by themselves. Negative 2y minus 2z equals negative 19. Now in the other equation, the bottom equation, I'm going to plug it in for x, and I get 4z minus 5 times negative 5y plus 9 equals 4. Distribute the negative 5, so I get 4z plus 25y minus 45 equals 4. Move the 45 over, so I get 4z plus 25y equals 49. Now I am going to take this equation and make them their own little system. So that's going to be 4z plus 25y equals 49, and then negative 7z minus 2y. Just kidding, got my variables mixed up. That's actually going to be negative 2z minus 7y equals negative 19. Now I want to make the 4 and the negative 2 opposite, so I'm going to multiply the bottom by 2. And that gives me, instead of this one, I get negative 4z minus 14y equals negative 38. Combine them, those cancel, and I get 11y equals 11. Divide both sides by 11, and you get y equals 1. Okay, so since you know that y equals 1, you can take it and you can plug it back in up here, and you get x plus 5 times 1 equals 9. So subtract 5 from both sides, so x is 4. And now that I have that, I can plug that in here. 4z minus 5 times 4 equals 4. Add 20 to both sides. So 4z equals 24. Divide both sides by 4. So z is 6. So my final answer point is going to be x 4, y 1, z 6. Okay, you can try this one with substitution or elimination, however you want to do it. I am going to give you the answer in just a second. Okay, your answer is going to be 2, 1, negative 4. This is the point where you show me what you know, so I want you to solve this system of equations, show every bit of your work, and have it ready to turn in to me at the beginning of class tomorrow.